All right, Dr. Elaine, welcome back from your trip. Now you get to hear all about how an archer is pulling back on the midpoint of the bowstring with a horizontal force of 162 newtons. What is the tension in the bowstring? Now, our two distances here of 72 cm and 35 cm at the bottom are both given. And what I did for this is I found the small segment of the bowstring that's touching the archer's finger, and that piece, I know that that piece of the string is in equilibrium, so the net force acting on it has got to be zero. And now drew my force body diagram up here with my axis being the normal y and y up and x horizontally. And I know that the force exerted on the string by the archer's fingers is going to be in equilibrium throughout all parts and segments of the string. So we can just jump right in it from here. And from the measurements given, we can find the angle theta by setting sine of angle theta equal to opposite over hypotenuse, which is 35 centimeters divided by 72 centimeters, and that is equal to 0.486 centimeters. And then we take angle theta is equal to the inverse sine function of times 0.486, and that is equal to 29.1 degrees. And then from here, we can see that the x component of the tension force exerted on the upper end of the segment is tension sub x equal to negative t sine of angle theta. And the x component of the force exerted on the lower end of the string is the same as I mentioned earlier, that they're all going to be the same, have the same tension on them. And that is equal to the sum of the forces in the x direction equal to negative 2t sine of angle theta plus f sub a. And that's all going to be equal to 0. And now that we know that, we're ready to solve for t. And we set t equal to f sub a divided by 2 sine of angle theta. And we plug in our values for that, and we get that the tension in the bowstring is 170 newtons.